I will be the moderator of this morning's program, which is the second in a series of webinars on asphalt paving training that we have been offering in conjunction with our friends at Working. This webinar series is representative of Kirby Smith's dedication to training and promoting quality in the asphalt training industry. We're following our last program of basic compaction with this morning's program of advanced compaction. It will be presented by our friend Tim Kowalski, who is the application support manager for Hom Rollers. Tim has a Bachelor's of Science degree in construction management from the University of Wisconsin-Madison and is a veteran of 23 years experience in the construction industry focused on quality control issues in the asphalt industry. I think you will enjoy Tim's presentation this morning. During today's program, we invite you to post any questions that you may have in the chat area located on the right-hand side of the screen, and I, in turn, will pose your questions to Tim. Our presentation should run about 45 minutes in length, ending at approximately 8:15. Tim, if you're ready to go, I'll turn this over to you now.
I'm ready. Thank you very much. I appreciate the offer and the opportunity to do this. Again, my name is Tim Kowalski, Application Support Manager for Woodkit America and Hom Rollers. My territory is United States and Canada. So what I am going to present here is not necessarily best practice, but what I've seen work around the country and people have developed into best practices. So this isn't the only way. It's one way of doing things that I have seen that have worked the best for what we're trying to show. You can also turn these into best practice once you look and put your input into it. So we're going to go through a little bit of an outline. We're going to talk about roller design specs affecting compaction. We're going to mainly talk about the amplitude, centrifugal force, and frequency, and speed, and how they all tie together. We're also going to talk about some external factors affecting compaction. We're going to talk about weather. We'll talk about temperature. And when we talk about temperature, there's three main temperatures that we talk about. We talk about the base temperature, the mixed temperature, and the air temperature. And one of those three we have a tendency we can control a little bit, but the other two, Mother Nature is in control of those. And then we'll talk about key factors that affect rolling pattern. And just the thought of the roller patterns, is main thing is just being consistent on what we're trying to do. And we'll go into more details as far as the roller patterns and how they can help you out. But briefly, just to get back from when we, the first seminar, Hom itself is over 102 years old now in 2013. So we've been around building rollers for quite some time. And a little bit of the time frame that we look at things is, we look at rubber tire rollers. They've been around since the 60s. We actually changed the design of the old ones to look a little bit more new from in 2010. Oscillation is something that we pride ourselves with. That was developed in '83, and that's come a long way as far as that goes as well too. But to get into more of the advanced compaction about this seminar that we're going to talk about, some of the key roller design specifications that affect compaction that we're going to look at, we're going to start with amplitude. Then we're going to go and talk a little bit more about frequency, the static weight of the rollers. We're going to talk about centrifugal force and how that affects it. And we're going to talk about roller speed. And roller speed and frequency tie together to make something very important called impact spacing. And we're going to talk about that and show some examples of that coming up here as well too. We're going to talk about drum diameter and how that affects the mix itself. We're going to talk about drum activation controls. And what I mean by drum activation controls is that we can set individual drums up differently versus what we could do in the past. And then we'll talk about drum water and scrapers. I keep telling everybody, if we do not have water on a roller for use for asphalt, we do not have a roller. I don't care if it's brand new or 20 years old. If water does not work, we do not have a roller. And then we'll talk about drum offset, something that is out there for a lot of manufacturers that a lot of operators do not use, but is a very good tool to have to help out in a lot of different situations. So when we talk about amplitude, we're going to talk about two different types. We're going to talk about low and high. And how they work is normally we have a sliding weight inside a case that when it goes in one direction, that weight will slide away from the mainstay weight, and it produces less offset as far as the weight down around the central axle. That we can run faster at a higher frequency, but it's a low amplitude. Now the other one, we can switch it in the other direction and slide that weight towards the mainstay weight, and we have more weight on one side, making a higher hammer or heavier hammer hitting. So we have a high impact or high amplitude. But that high amplitude, we can't spin as fast, so our frequency isn't as high. So the other thing I also want to say too is you cannot switch these on the fly. You want to switch these definitely when you come to a stop. It's hard on the equipment. Plus, it also could be detrimental to the mat as well, too, when you're trying to change from a low to a high amplitude in midstream of compacting material. So we definitely want to make sure we're stopped when we make that change. And this is what it really looks like as far as the weights going around the center axle. And a lot of people think that the vibration mode is straight up and down, but it's not straight up and down. It's actually a circular motion. And you can see in the animation there that that drum is actually moving in a circular motion as the weights are going around that center axle. And inside the orange housing that they show here is where that slidable weight is. So when it's going in one direction now, it might have the weight all the way away from the stationary weight, so we're going to be in a low amplitude. Where if it rotates in the other direction, that weight will slide back to the other stationary weight, and we'll have a high amplitude, or we will not be able to spin it as fast. So that's basically the mechanics of a vibratory drum. Now when we talk about controls, we can control the front and the rear drum individually. So we can have the front drum on a high amplitude, we can have the rear drum on a low amplitude, we can change the frequencies, we got a lot of variability that we can do with a roller. My concern is we definitely want to make sure whatever we're changing and make sure the frequency is the same so that the roller is in sync with everything. When we talk about centrifugal force principles, usually the heavier the centrifugal weight, the greater the generated force, or the faster the eccentric rotation weight, the greater the centrifugal force. This is kind of how the theory when we came up with high frequency rollers. If you take a standard vibratory roller, the highest it's going to be able to run is probably around 3,000 BPM on a low amplitude. With a high frequency, you'll be able to get up over 4,000. But the reason we can get up to 4,000 is because we have a smaller weight. But the 4,000 versus 3,000, we should have the same amplitude force generated in the material. If you take the 4,000 BPM roller and drop it down to 3,000, you will not have the same force as a standard 3,000 BPM roller. So that's the theory behind the centrifugal force principle. Now, we can also calculate that. And here's a simple calculation. If you multiply the amplitude times the unsprung dry weight times frequency squared divided by 35,198, you can get the centrifugal force. I kind of throw that in there. It's kind of funny, but it actually is a calculation that does work, and you can calculate centrifugal force. And there are some locations, some states do require a certain centrifugal force for each roller that's going to be used on certain types of mixes. So each state does have some kind of specifications that will ask for that. So there's a quick calculation that you can come up with to find out what the centrifugal force is for the roller. Now we're going to talk about frequency, and we're going to talk about speed and how they can affect what we can do. But the main thing to know is that speed can kill. And what it means kill, it's going to kill your density. Because there's the next example here. If we have a roller that's doing about 3 miles per hour, and we have impact spacing, or we have the VPM set up about 3,200 VPM, we're going to have a set amount of spacing that we're going to be able to have for linear foot. And if we're going at 3 miles per hour, 3,200 VPM, we're approximately 1 impact per inch or 12 impacts per foot. 12 is kind of a magical number that we like to look at because we figure that's where we're going to get the best results. If we start going below 12 impacts per foot, we have a tendency to decrease the ability to get density. We also might have a chance to build in rougher ride and build in chatter marks. So we want them 12 is kind of the minimum we want to look at. Now the same example, only we're taking that same VPM of 3,200 VPM and we're increasing the speed from 3 to 4 miles per hour. We go from 12 impacts per foot down to 9 impacts per foot. So now we're getting into that area where we're almost leapfrogging trying to get our compaction. And what this is going to create, it's going to create us to go more passes. So as we speed up, doesn't mean we're necessarily going to catch up to the paver. We actually might even be going slower because we have to make extra passes to try to get the density. So a lot of times we can actually go slower, but actually go faster by going slower because we're doing more impacts per foot. We'll do fewer passes and be able to catch up to the paver. So what I usually like to tell people is make 12 impacts per foot kind of the minimum. If we drop down below that, we're going to be susceptible to either struggling getting density or we're going to have a hard time getting out some of the marks that are in there. And with the specs that are out there and what's out there, his ability for bonuses for smooth rides, we want to make sure that we're going to eliminate any possibility of not getting that bonus. So 12 impacts per foot is kind of a magical number. You never usually have to worry about the number going too high because people never go too slow. I've always seen paving going faster than slower. Normally, though, if you also don't want to go up with too many impacts per foot, especially if you're on like a low amplitude with a high frequency, and we get up above 20 impacts per foot. That low amplitude will start acting like a high amplitude because we have too many impacts per foot now. But that usually never is the case. But remember, 12 is kind of the rule of thumb. Between 12 and 16 is a good number to think about. And on most rollers, or some rollers, like our HD Plus models, we actually have a gauge that will tell us that, and we can set that up based on what our forward speed is and what our frequency is set for each of the drums. The left side of that graph is for the front drum, the right side of the graph is for the rear drum. And when we change either our speed or our frequency, we'll see that gauge go up or down, and it'll be able to tell us what our impacts per foot are per drum. So for an example, if we're going to 2.7 miles per hour, and we got a drum set up 3,000 BPM, we're running about 12 impacts per foot. And that's about where we want to run, 12 impacts per foot. Remember, we don't want to go lower than that because we're going to be pushing the limits of building in problems. We also, there's several charts. We actually do have a magnetic chart that will stick on any roller that relates to this. And you can see, if you know what your VPM is set up at, and you know what your roller speed is set at, we can actually find out what our impact spacing is on the chart. Now remember the last example, we had 2.7 miles per hour. If we follow that down at 3,000 BPM, that's right around the 12 impacts per foot. So the gauge is pretty close to what we're showing here. And there is a calculation that you can do by hand too as far as getting that, but it's much easier to look on the chart based on your speed. Now here, this one shows at about 3.2, we're at about 10 impacts. That might be a little borderline as far as pushing it. We want to make sure we're up around that 12 impacts per foot spacing. And how we do that is basically if we can control our forward and reverse speed, be consistent, we should have consistent impact spacing. If we have where we're having the operator control it manually, sometimes we're going 3 miles per hour, then maybe 2.5, we're going to get what's called an accordion effect about that impact spacing. Sometimes you're 10, sometimes you're 14, then maybe down to 9. Well, that inconsistency is going to change your ability to compact that material and get consistent density. If we stay at a constant speed, we have a better chance of having consistent impact spacing, therefore having more consistent density throughout the map. Some of the older models, we actually didn't have a gauge, but we had it on the speedometer. But I know I'm not that old, but those numbers are pretty hard to read when you're trying to concentrate on rolling down the road to see where you're at. So we've definitely made some improvements on that. But we also, this is the main thing we don't want to do. We don't want to build in ripples because, number one, it does a couple things. It could reduce the rideability, and we also could be just crushing aggregate, which is something we don't want to do as well, too. So we want to make sure we got the right spacing and the right speed that we're working on. This is another example of a project that I was down in Georgia on. They couldn't believe they had a very rough ride, and it sounded like there was a noise in the mat. Well, that's a 1 foot ruler, and if you look at the white spots on the ground, that's where the impact is of the roller. Now remember, the magical number we talk about is 12. Looking at that, that's 4. That's 4 impacts per foot. So really, at 4 impacts per foot, we're going to have to run 3 passes just to get what we could do with 1 pass. Not a very good thing to do. As you can see, I don't know if you can see from the picture, but you can see the ripples in the roadway. And it definitely is something we want to make sure we don't do. Now, the speed of the roller, that was going super fast, did not know what his VPM was, did not know what his amplitude setting was, so he didn't know what his impact spacing was. I do know that the paper was doing about maybe 100 feet a minute, and they only had 2 rollers to try to catch up. So they were trying to roll as fast as they could to keep up and still try to get density, but it wasn't there. So we just got to watch our speed to make sure that it matches up with our frequency to get the right impact spacing to get the proper density. So when we look at the energy that we want to put into the mat, we can change that frequency. If we slow down but we want to maintain our impacts, we can increase our frequency or decrease our frequency. However we do, if we're going to speed up or slow down, we just want to make sure that our impact spacing stays the same so that we're going to get the same kind of energy per inch of compaction effort. Now we also talk about an automatic mode and a manual mode, and probably 99% of the time most people are going to run in manual mode. And only thing I will caution about manual mode is sometimes we have a tendency to shut off the vibrations too soon and start them back up too late. And what that does is in the locations where we're starting and stopping, the mat is compacted, but it's not compacted using vibrations, so we might not be getting density. So the longer we make those areas, the harder and harder it is to get consistent compaction and density because it's rolled, but it's not compacted using vibration. So I tell people, I said, when you're ready to start making your turn to come to a stop, that's when you turn your vibrations off, and you shouldn't have to go any further than 1.5 lengths of the road. That's all the further you need to do. And when you're ready to start back up, as soon as you start going in reverse, start the vibration up, because by the time you straighten that roller up, that's when the vibration should reach its top frequency, and we can narrow down those crossover areas to get a better chance of getting more consistent densities even in the crossover areas. The other thing too in the crossover areas, I always tell people make sure that you pass through them to stop on your next passes. Don't stop in the same location because you're going to have a better tendency of building a bigger bump. So we talk about drum diameter. Why does that play a role? Well, if you look at the small drum on the left-hand side, you notice that it's pushing more material in front of it. It has a greater angle of attack. Therefore, it has a tendency to want to push more material in front of it instead of carrying that material underneath. It does a couple things. It creates a bigger bow wave so that when you come to a stop, you create a bigger bump. But also that material has to come from somewhere, and normally it's coming from underneath the roller, or it's cracking that material behind the drum because it's separating it. So with the larger drums, we have a much lower angle of attack, which means more of the material is going underneath the drum, which means when we come to a stop, we're not going to build a bigger bump, and we're going to have less tendency for cracking behind the drum because we don't have all that material being pushed in front of the drum. So drum diameter does make a difference as far as the compaction effort and what we're trying to do with the material. Pressurized water system, like I said before, if we do not have a water system for an asphalt roller, we do not have a roller. I don't care if it's brand new or 20 years old. Sprinkler system is key to the success of a roller for asphalt. Now that being said, there's a reason why there's 2 dual scraper systems on rollers as well too. They have a dual function. When they're going in one direction, if you're taking that roller and going from left to right, the far right scrapers on the rear drum, the upper one acts as a water trough. It's up against the drum and the water sprayed on the drum, the water hits that scraper and it gets distributed across the even width of that drum. The other scraper picks or scrapes off anything off the drum that it might have picked up as it's compacting. Now when the roller goes in the other direction, the rolls of those scrapers reverse. If the scraper on the bottom now becomes that water trough to distribute the water before it goes under the ground, and the one up on top now becomes the scraper taking anything off. So if we do not have good scrapers, a couple things are going to happen. We're probably going to use more water. If we pick anything up, we have a less tendency of scraping it off or taking it off the drum, so now we have to stop. So the more water we use means the more stops we're going to have to make to refill. When we make more stops to refill for the water, what does that do? It takes us away from time for compaction. When we're taking away time from compaction, we're getting further and further away from the paver. When we're getting further and further away from the paver, the mat is cooling. As the mat is cooling, it's stiffening up. As it stiffens up, it's harder and harder to get compaction. So the more time we spend trying to get water is less time we can get compaction in that field. So we definitely want to make sure we're only using the amount of water that we need to keep from picking anything up on our drums. We can spend more time behind the paver, better chance of getting consistent density. When we talk about offsets, a lot of rollers, I know our HD Pluses will offset about 6.7 inches. They're great for pinching joints, doing unsupported edges. If you have a mix that has a tendency to be a little tender and mark up a little bit from rolling, we can offset those drums a little bit to reduce the amount of cutting that it's doing. If we're doing a lot of curb work, we can move the rear drum away from the curb and put the front drum up against the curb. That way when we pull away, the rear drum's not peeling out that curb. Also, if you just need a little bit more coverage than what the width of the roller will allow you, remember, we got another 6.7 inches per pass that we can add to a coverage. So we can offset and pick that up if we need to. And how do we do that on ours? We have buttons down below. If you hold the left side one, it'll offset that rear drum. If you press and hold it, that's 6.7 inches. If you want to just offset it a little bit, just press and release it a little bit, and it'll move out just a little at a time. If you want to center the machine, you press both buttons at the same time, and it'll automatically will center those drums front to rear. When the lights go out, that means the machine is centered. So now we're going to look at some external factors that affect compaction. And I don't think that's a nuke suit that guy is wearing, and I know nobody ever paves in the rain. So this should not affect anybody. But guess what? With the mix designs, there are several different types of mix designs that are out there that change the way we try to compact. We have super paved mixes, we got SMA mixes, we got polymer modified mixes, we got open graded friction courses, we got thin lifts, we got thick lifts. A lot of the designs, we're not going to be compacting the same way. So understanding and having the knowledge of what you've done in the past helps you get through and get better compaction and better density. Mixed temperature, if we have a plant, that's the only temperature we can control to some extent. A lot of that will have to do with what our halls are going to be. We might have some paver issues, might have some operator issues. The ambient and base conditions. Base conditions, when we talk about that, we do not have a good base to pave over top of. We're not going to have a good, long-lasting, durable surface mix that we're going to put over top of it. So base conditions is critical. And asphalt, really what it is, it's basically just a combination of different size aggregates with a certain type of bitumen added. Now, we also don't want to have all those particles to be round marbles because we'd never be able to make a pancake out of the roadway. We'll make a 15-foot road out of a 12-foot road. We want to have some of our aggregates to have some fractionation to it so that we can have some aggregate interlocking so we get some good load-bearing capacity of that material. We want to have a little bit of round stuff in there just to help get the compaction in the shape, but we want to have more of that aggregate interlocking for the bracing. Not too many flat and elongated pieces because once we vibrate on top of those break apart. We have an open aggregate spot. I have a tendency to maybe force some water in there, separate the oil from the rock, and we can get some stripping. So we got to be careful on how much that is. Now, when we talked about the old mix designs, we talked about old Marshall mix designs, and they had an old rule of thumb that if you had a half-inch top-size rock a 1-inch lift would be sufficient enough. Well, that was fine with the old Marshall mixes when we had a lot more rounder stones in. And we didn't have vibration on some of these rollers that we have today. It was all done with static. Well, now, with the super pave mixes, that kind of rule of thumb has changed. That same half-inch rock, now we want 3 to 4 times the size. So we got 1.5 to 2 inches. Now we can manipulate those materials better in place to get a better load-bearing capacity with the vibration on the rollers that we have. One thing we also want to be careful about is that same half-inch mix. If we're going too thin, we have a tendency to do some grain crushing with the size rollers we have, especially if you're running it on the cold side with vibration. Once we start breaking rock, we start destroying the mat. That's the side that's going to start failing on us first. So we need to be careful about that. I show this picture here because not every roller is suited for every project. We want to make sure that we get the right size roller for the project. It's showing an HD 14 for some small cul-de-sac city work that we're doing thin lifts on. It's a heavy enough roller, but agile enough to work. We're going to be able to get around, turn around, and not tear the mat, and still be able to get good compaction with it. If we don't want to run an 84-inch wide roller on this, it would be just an oxy thing to get around, and we want to make sure we set up the right roller for the right project. This is an example of a cooling rate, and I use this chart quite often because what it does, it shows us a range that we can set up and have the ability to run our compaction. So here's an example. We have a 3-inch mat. The delivery temperature of the material is at 275 degrees. The air temperature is 50 degrees. The surface temperature is 50 degrees as well. When I hit calculate, we have a window of opportunity of probably around 40 minutes. And that 40-minute window of opportunity is how long before I have to shut my vibrators off and just start destroying the mat. So I got a little bit of time that I can play with this and get the initial compaction. Now if I look at the same, everything's the same, but I drop that down to 1.5 inches and recalculate it, I go from 40 minutes down to about maybe 15, maybe 12 minutes. So now the thinner lifts with the same temperatures, my window of opportunity has just gotten narrowed down. A lot of times when we're doing thinner lifts, what's the paver doing? It's running faster. So I have less opportunity to try to get the initial compaction. So I have to be it's very critical that I understand what my window of opportunity is before I run out of it. Great chart to have, and it's a free chart that you can get. If you actually go to pavepool.com, you can actually find that chart and utilize it. I use it very often. So when we look at temperature ranges, and this is just in general when we had for general mixes, normally a breakdown roller anywhere from 310 to 240. And then less than 240, we still have the opportunity for the intermediate roller to try to gain some compaction. We also look at different widths of or different lengths of their roller patterns. I set up around 200 feet. We don't want to have them too close or too short because we'll have too many crossover areas, which I call dead zones, so we want to be careful about that. That actually will increase the amount of bumps. But we also don't want to have them too long. If we have them too long, we concentrate too much on one side of the mat and forget the other side that's cooling down at a high rate, especially if it's a thinner lift. So we want to make sure we're not too long, but we're not too short with those passes. Secondary roller, if it's a rubber tire roller, normally we don't usually set up a roller pattern for that. It just should never stop. I have yet to see a rubber tire roller in the secondary position that's hurt any mix that's out there, whether it be a thin lift or a thick lift. So the rubber tire roller should never stop. Finish roller, normally we don't use vibration on a finish roller because it's dropped down below that temperature that we want to save any density for and save the mat as far as smoothness goes. What we can run back there if we do need some extra compaction is if you have oscillation. You can always run oscillation when you can't run vibration. So it's always a good thing to do too. While the cooling rate, like I showed in the example in that chart, is affected by the mat lift thickness, like I just showed, we went from 3 inches to 1.5 inches. You can see what that does. But when you talk about the ambient and base temperatures, those have a lot to affect it as well too. The colder it is out there, the narrower that window of opportunity is to get that compaction. The asphalt mix laydown temperature, if we're laying down a polymer modified, you don't want to be laying it down at 280 degrees. You definitely want to have the heat in it, otherwise we're going to struggle trying to get any kind of compaction. Wind velocity. If there's no wind versus a 20-mile-an-hour wind, you will get a very quick rate of cool down as well, too. So when you look
Tim,
at... yeah.
Tim, Gary Corley, we've had a question about warm mix designs. With the warm mix, would you recommend paving slower, or is it better to add more compaction equipment, more rollers?
Well, it all depends on how thick you're planning on laying it. I would also recommend making sure that when you do pave it, that you actually have the vibrators on the screed, because that's free compaction. The only thing is just got to make sure with warm mix that you don't let it cool down too much. As far as having more rollers out there, all depends on how thick we're going to plan on making it, how far the plant is away from the job site. There's a lot of little factors that we can do. Typically, though, normally warm mix, you really shouldn't have to do a whole lot different than what you do in hot mix.
Very good, thank you.
Did I answer the question?
Yes,
all right, well,
thank you.
Okay. Well, moving on, we also have the ability to have temperature sensors on the rollers where we can actually read out what the temperature is, and maybe even with that readout, we can set a high and low limit or a range that we want to keep that roller within, so that we know we're going to get more consistent results when it comes to the compaction we're looking for. So at a high limit, if it's above that limit, it'll beep and flash at you. If it gets too low, it'll do the same thing. It'll beep and flash at you saying, all right, it's too low, we need to move on and get moving. When we look at base conditions, like I said, is it just a surface mix or has it gone deeper than that? We want to make sure we have a good solid base to compact on, because of a weak base, pulling the paver through is not going to make it bridge with the asphalt. So preparation is critical, whether it's just surface and we want to mill it and fill it, or if it's gotten down deep into the base, we need to do something different, like some kind of a stabilization. Because just putting an overlay on top of something that's gotten into the base like that, you're just going to have more problems in the future. It's just going to be putting a Band-Aid on something that needs stitches. So whether we're doing the milling or we're doing full depth reclamation or some kind of a recycling process, we want to definitely make sure that the material that we're leaving behind is going to be a smooth material. Because anytime we have, especially on thinner lifts that we're going to be doing, especially when it comes to fine milling, any kind of deformation or variance in that thickness is going to be really critical to how we're going to be able to get that compaction, especially when it's on thin lifts. So the smoother we can make it on the bottom, the smoother we're going to make it on top, and the more consistent densities we're going to have all over across, the longer lasting pavement, smoother rides, and a possibility of bonuses down the road. So when we look at walking around the rollers for startup, we want to make sure that nothing's out of the ordinary. We want to check the water system, clean the filters. On ours, we have 3 filter systems, one down in the tank, one in the openings for the fillers, and then also in the nozzles themselves. So we definitely want to make sure we check the filter system. Check all the lights, especially if you're doing night work. Make sure all the lights work, head, both front and rear, the beacon lights and so on. Check fluid levels. We want to make sure that we check the scrapers, make sure they're in not only the down position, but the right position. If you're going to be starting out right away, make sure they're down. If you're going to be traveling down the road a bit, make sure they're off the drum so we're not wearing out the scrapers. Allow for the equipment to warm up, and just like anything else, know your equipment. I put in here as far as some things for using in vibratorial, deactivate vibration before reversing. I did run across some folks that actually kept the vibration on when they came to a stop. Not a good thing for smoothness. We won't get that bump out. We want to choose the amplitude and frequency to match the job and the mix as far as the mix type and the mix thickness that we're placing. Compacting surfaces, I usually like to start out on a low amplitude with a higher frequency, because then I can always go to a higher amplitude with a lower frequency with more force if I need to. Unless we're compacting mixes, maybe 3 inches or more, and that number will vary depending on the type of aggregates that we're looking at and the oil that's in there. But then normally we want to get that initial compaction right away, so we want to go to a high amplitude with a lower frequency. On hills, we want to only vibrate, especially if they're steep hills, we want to vibrate uphill, but we want to come back down static. If we vibrate coming downhill, we're going to end up having that mix all the way at the bottom of the hill. So we do not want to vibrate going down. Now, typically 175 degrees Fahrenheit is typically where we talk about stopping to use vibration before it starts damaging the mat. And if that's the number that we're going to look at, that's where we can still have enough temperature in the mat. We can move it. Oscillation works well, but normally we're going to be going to static as well too. We want to roll as close as possible behind the paver, but we do not want to hit the paver. People that are on breakdown rollers have a tendency to want to come up and always kiss the back end of the roller. Well, number one, that's fine and dandy, but it's a safety hazard because we don't want to run into anybody that's sitting on the paver or standing behind the paver. As long as we're within 10, 20 feet of the behind the paver, we're up to the paver. We just do not want to hit the paver. We always want to begin on the lower side or the downslope side of that pavement so that we can bring everything back up towards the center, which is normally going to probably be our center joint. And we want to make sure that all material is there first. Compact the seam first. Some people do that. I don't usually like to recommend it. I like to have that warm mix or the hot mix warm up the cold joint before I decide to seal that. So I always start on the low side, bring everything up, and then compact the seam in the last pass. Deactivate vibration before reversing. Always change roller speeds gently. We don't want to have jackrabbit starts and stops because that's just going to build in problems as well too. We want to move forward and backwards in the same track. We don't want to be zigzagging down the road. We want to make sure we're being consistent on our passes. We want to change the roller track on the cold side. And if possible, if you can get off the mat totally. Get off the mat totally and come back on, because that'll reduce the stop marks that you have in the mat with that roller. You're still going to leave some dimples. Roll in parallel tracks next to each other. Don't want to be crisscrossing. Water the drums sufficiently. We only need enough water on the drums to keep from picking anything up. We don't need to be overdosing the water on the drums because it does a couple things. It uses too much water. We're going to be stopping refilling too much. Plus, it cools the mat temperature down, so it reduces the ability to get the compaction. Never leave a roller on the hot asphalt. If you any chance you're going to stop, if you can pull it off the hot spot or hot mat, put it on a cold mat, that'd be great. Don't stop behind the paver and sit there and chat with the guys behind the paver. Your eye should be on the drums just to make sure that you're getting sufficient water. You're not picking anything up. But they also should be on the mat both in front of you and back of you so that you're not running anything over or anyone over. The main thing is just to be consistent. That's what we want to do. So some key factors affecting rolling patterns are basic rolling techniques, our paver speed, the number of passes, and the number of coverages, which are two different things, and then joints and edges. So basic rolling techniques, we definitely never want to stop on a soft mat. We never want to vibrate standing still because the weight of that roller will definitely sink into the mat and you'll never get those dimples off. That will not be for a good ride. We talk about overlap. We want to do at least a minimum of a 6-inch overlap. And the reason why we say a 6-inch overlap, if you ever happen to look behind a roller when it's rolling down a fresh mat, on either side of the roller there's a little wave that will go out from the edge of the drums. And that wave is about maybe 4 to 6 inches. So that's why we always like to overlap 4 or 6 inches so that we can take that wave out on our next pass. Again, we want the smooth starts and stops because we don't want to leave a big bump or tear that mat when we come to a stop or when we start back up again. Always stop on an angle, whether it's up towards the paver or back behind at the beginning of the pass. Always stop on an angle because we have a better chance of getting that out than if we don't. And here's an example why.
A while back, I saw a demonstration of a rolling pin and a block of clay. Trying to roll out a transverse mark in the clay was real tough and only created a larger dip. Rolling out an angled mark was easier, and you can get a smooth surface. I say it's like that in the field, too.
And that gives you a better idea as far as why we stop on an angle, so that we can get that bump out and get smoother rides. Now, number of passes, that varies from what I've seen around the U.S. and Canada as far as what people are looking for as number of passes. My idea of a pass is anytime you go in one direction, you create a density. When you come back in the other direction, you create density again. So that up and back motion is 2 passes. Some people actually call that 1 pass and not 2. I always call it 2, but it's always good to understand your reference as far as what you're calling a pass. And each roller is going to have its own pattern. Breakdown roller is the one that's going to be the critical. Rubber tire roller, like I said, it just never needs to stop. But the finish roller, you might want to establish a roller pattern as well too. And also, a lot of times people tell me they've done 8 passes or 6 passes. I have a hard time understanding that because normally it's always an odd number. The odd number is always catching back up to the roller. Pass 1 is up to the roller, pass 3, pass 5 is always back up. Start your next passes. Now, number of coverages, it's the number of passes to cover the mat once with the roller. Not necessarily how many passes we're running, but how many coverages it takes for that roller width to cover that whole width of the mat. So that's where the coverages and passes are different. We also want to make sure that when we change the rolling tracks, that we always change on the cold side, or if you have the opportunity, always change off the mat if you can. If we're paving an echelon and we have a crown, we always want to start from the low side and bring everything up to the middle. That way we can bring all that material to the center line, center joint, and create a much tighter sealable joint, and we'll have fewer problems down the road. If we're paving an echelon and we have a third pass that one of the roller needs to make, we always start from the outside and still go towards the center where that joint is between the 2 pavers. And that third pass will be alternated between each one of those rollers. We don't have the one roller always doing 3 passes, the other one always doing the 2 coverages, the other one doing 3. We'll alternate from section to section who's going to be doing it. So an example of a 5-pass pattern, if we have 2 unsupported edges, normally you're going to go up, staying just off the outside edge with vibration, come back in static. If that's not enough, we usually start right back over again. We'll start back with the first pass. We'll come back again with the second pass, third, so we'll have 8 passes that we'll be able to do that with. Now, normally if we're going to have a last pass, if it's a 5-pass pattern, normally they'll, most time everybody will go up the center. I always tell everybody, go up the side of the pavement that you struggle the most getting density with. Normally it's going to be the outside edge or the unsupported edge. But if you go on the outside edge, on the downside, when you get to your next pass, you just need to keep going straight. You don't need to have to worry about moving back down or moving back up, whichever way you do it. Now you just keep going straight into your next passes. So it works out well. If you have two confined edges, if there is somewhat of a slope, always start on the low side and work to the high side. Always go against gravity. This is one time where I like to pinch the joint first, is if we're up against a hot mat, not a cold mat, but a hot one, we'll pinch that joint and seal it right away. But we'll also then start on the outside and move back towards the center to bring more of that material to that joint to make a much tighter joint. When we talk about longitudinal joints, I always like to wait and compact that joint, let the hot mix warm up that cold joint so that we're going to have a better sealable bond with the 2 mixes. But when you're going to do that joint, stay 4 to 6 inches off so your pass up. We'll have both drums behind each other in vibration mode, but when you come back over top of there, make sure you turn the vibration off, because all we're going to do is start destroying the cold side of that mat. And this is an example of what that does when you vibrate on that cold joint. You're only going to be able to compact that hot mix down to the level of what the cold mix is. But once you get to that level, all you're going to start doing is you're going to start breaking the rock, and you're going to start what's called white topping. And that's the side of the joint that's going to fail first. So we can actually do this with one pass if we're using an Aussie roller, where we have the front drum offset about 4 to 6 inches from the joint, the rear drum running oscillation covering it up. So we can cover that with one pass, and we get a much tighter joint. And with oscillation, it's not like vibration. It's going to scoot across that cold surface, and it's not going to destroy the mat. As seen here, it's not going to bust up any of that cold side, but it's going to manipulate that hot mix into place to get much better compaction than trying to vibrate it and then destroying the cold side of that mat, which we don't want to do. So same thing with a transverse joint. Normally we're not going to vibrate because we got about 90% of the roller on the cold side. We're overlapping about 6 inches. We're going to run it static. If we have the opportunity, we can run it with oscillation, get a much tighter joint. Remember, even if we're 90% on the cold side, we're not going to be destroying that cold mat either. Here's another example of how that looks. A lot of times we do not have the opportunity to go all the way across or all the way back perpendicular to the mat. Sometimes you just need to do the best you can with that. Well, definitely only overlap about 6 inches. We start overlapping too much and getting too much of that roller on the hot mix side, we're going to end up bridging, and we're going to have a high point or a low point with the outside edge of the mat or outside edge of the drums on the roller in the hot mix side and create a divot. So we don't want to do that. Unsupported edge, like I said, in the first pass, we're going to run vibration. Second pass, coming back on that outside edge, we do not want to run vibration. We want to run static. So we're going to compact up using vibration, but then we'll use just static coming back. Now, the other thing we can do, we can also use oscillation. We can do it one pass where we offset the drums, do it one pass up, or do a single pass up using vibration and oscillation, and when you come back on the outside, just turn the vibratory drum off and run oscillation. The reason we do that, we get better consistency as far as density on the outside edge and a less chance of that outside edge breaking off. So in summary, the specs affecting compaction we looked at, we talked about amplitude, frequency, and speed, and how speed and frequency are tied together for your impact spacing. Remember, 12 is the magical number that we're looking for. External factors that affect compaction, we talk about mix type. There's several different types out there. The temperatures, we talk about 3 different temperatures: the base, the mix, and the ambient temperature. One of those 3 we have somewhat control over. That would be the mix temperature. Base conditions, if we don't have a good solid base to build on top of, we're not going to have a good material to be riding on top of. Talk about roller patterns, always go from the bottom side up, bring that material to the joint. We've always struggled with having good joints around the country, and the reason why is we start at the center joint and push everything away from it. Gravity has a tendency to help us along. The main thing, though, is to be consistent in whatever we do. Roller passes, impact spacing, speed, frequency, understanding the mixes and how to be set up that roller properly to give you good density. And with that, that is all I have. I would be welcome any questions or comments, or if anybody wants any more information, feel free. There's my information. Contact me if you like. But again, thank you very much for allowing me the opportunity to present this to you.
Tim, thanks for another excellent presentation. It's very beneficial. Just as with our last program, this presentation has been recorded and is available on our website. It can be downloaded and viewed at your leisure. If, of course, Tim's information is on the screen. If I can be of service to anyone answering questions about anything that you've seen on the compaction presentations, or about any of our fine family of working products, I can be contacted at gcorley@kirby-smith.com. I'd love to hear from you. Our next webinar is going to be on basic asphalt paving. The time and date is yet to be decided, but it will be announced on our website and via e-blast. With that, I thank you very much for your attention this morning. Be safe on the road, safe on the job, and have a great day.